Here is your Section 7.5 recap video of hypothesis testing for variance and standard deviation. First, we need to cover how going to find a critical value for the chi-squared test. First, specify the level of significance. 2, determine the degrees of freedom, which is n-1. 3, the critical values for chi-squared distribution are found in Table 6, or we can use Excel and use the following guidelines. For a right-tailed test, left-tailed test, and a two-tailed test. For where we put in our percent, for a right-tailed test, you're just going to use alpha. For a left-tailed test, 1 minus alpha. And for a two-tailed test, 1 minus alpha over 2. So if we go over here in our Excel file, we can find in here, if I go and find statistics, it's going to take me a minute, sorry. I normally have it at the top. We need to find our chi-square. So chi-INV. So we notice that we need our degrees of our probability. So we would type in here either alpha, 1 minus alpha, or 1 minus alpha over 2. So let's just go 0.05. And then our degrees of freedom, I'll just make something up as to 14. And that's what you're going to use to find your information for that part of this section. Now here's just some pictures to look at. For a right-tailed test, this is why it's alpha, because over here's 1 minus alpha. For left-tailed, our rejection region is alpha, and this is 1 minus alpha. And for a two-tailed, this is 1 minus alpha, and we have to use half of this and half of this. Now, Excel, we have to use 1 minus alpha, so that's a little different, but each of our rejection regions is the area, and this one's half area because there's 2 of them. So find the critical value chi-squared for a left-tailed test when n equals 11 and alpha equals 0.01. First, degrees of freedom. 11 minus 1 is 10. Second, degrees of freedom equals n minus 1, 11 minus 1, which equals 10. And the area to the right of the critical value is 1 minus 0.01, which is 0.99. So alpha in this case is 0.01. And so from Table 6, we can see the critical value is this, or we can go use Excel. So if we want to use Excel, we now have a probability. We need to do 1 minus, since it's left, we're going to do 1 minus alpha, which is 0.01, and degrees of freedom is 10. All right, I've done something wrong here. 0.01. Oh, I put a comma. All right, so we just need to do 0.01 since that's our alpha and we're finding the left. And we type in 10 and we get out 2.558 to be our critical value for this part. Now, here's our steps for our chi-square test. We need to identify our different information. So first, we need to know what our test statistic is. Well, it's S squared in this case because we're doing standard deviation and variance. Now we know this is variance, so if we need to find standard deviation, we have to take the square root. Okay? Now the test statistic is S squared. The standardized test statistic is chi-squared equals n minus 1 times S squared divided by sigma squared. This is from the sample. This is from the population. And this follows a chi-square distribution with degrees of freedom equaling n minus 1. So here are our steps. First, state the claim mathematically and verbally. Identify the null and alternative hypothesis, which means state H naught and H alternative. Specify the level of significance, which means identify alpha. Determine the degrees of freedom and sketch the sampling distribution. We know to find degrees of freedom we equal n minus 1. Number 4, determine any critical values and determine any rejection region. So we can use Table 6 or we can use chi-inverse in Excel as well. Find the standardized test statistic, and here it is, chi-squared equals n minus 1 times S squared divided by sigma squared. Make a decision to reject or fail to reject based on where it falls in the region. Interpret the decision in the context of the original claim. So let's try it. A dairy processing company claims that the variance of the amount of fat in the whole milk processed by the company is no more than, that means less than or equal to, 0.25. You suspect this is wrong and find that a random sample of 41 milk contains containers have a variance of 0.27 at alpha equaling 0.05. Is there enough evidence to reject the company's claim? All right, so the company says it's less than or equal to 0.05. You disagree, so your claim is that it's greater than 0.25. Our alpha is 0.05 as given in the problem. There are 41 people in the sample. We subtract 1, get our degrees of freedom equals 40. Here's our rejection region. Since this is greater than, we know this is right-tailed, so we have to find this. How do we find our critical value? Well, considering it's to the right, let's go over here and use our Excel. We know our thing is 0.05 and our degrees of freedom is 40, but since it's to the right, we have to subtract 1 minus, and we get 55.758. So now if we go back to here, we've already stated this stuff, we get 55.758, perfect, that's what we found using Excel, using chi-inverse, and we had to use 1 minus alpha, with 40 being our degrees of freedom. Now there's the test statistic. N in our case is 41, subtract 1, times S squared. Our 0.27 comes from, if we look back at the problem, when we did our symbols, when we found our test, it got 0.27. Theirs, which is the population, is 0.25. So we go back to our test statistic. It's going to be 41 minus 1, what we found, what they gave us. All right? And then 43.2. So again, it's really degrees of freedom, or 41 minus 1, times 0.27, which is what we found because it was a sample, divided by what they gave us in the population to be 0.25. We get 43.1. We notice that that falls in this region, which is our fail to reject region. So we're going to fail to reject, and we can make a conclusion that at 5% level of significance, there is not enough evidence to reject the company's claim that the variance of the amount of fat in the whole milk is no more than 0.25. Now this is all variance because if you notice, S is squared and sigma is squared, okay? If we're going to do standard deviation, it's a little different, so let's practice one of them. A restaurant claims that the standard deviation in the length of serving times is less than 2.9 minutes. A random sample of 23 serving times has a standard deviation of 2.1 minutes. At alpha equals 0.1, is there enough evidence to support the restaurant's claim? They say it is less than 2.9. So what's our claim going to be? Well, if we look at H0, if theirs is less than 2.9, we have to go the opposite, greater than or equal to 2.9. So this is technically our claim this time. The null is. We go to look at our problem, and their alpha is 0.1. 23 people were in the survey that we did. Minus 1 equals 22. Now let's draw our rejection region. Since this is less than, we know it's going to be left-tailed. Now to find this 14.07, let's go back to Excel. Chi.inverse. And now, since it is left-tailed, I don't have to do 1 minus. I just type in 0.1, and my degrees of freedom as 22. That's going to give me 14.04. So now when I look back at my problem, I know that my critical value is 14.042 right here. So what I need to find out is if it falls over here or over here. If it falls over here, reject. Over here, fail to reject. So now let's do our test statistic. All right, n minus 1, s squared, sigma squared. 23 minus 1, because that's how many people. We found out when we did ours, it was 2.1 squared. You can see that in the problem. And they gave us the population standard deviation, variance, so it was 2.9. Now, our decision is to reject the null hypothesis because we got an 11.536. That falls to the left. So at the 10% level of significance, there is enough evidence to support the claim that the standard deviation for the length of serving times is less than 2.9 minutes. That's it for this section.